morning, everyone. My name's Julie Ma, and I'm the newest co-PI on the Open On Demand project. Joined this summer. Anyway, I'm really thrilled to be here today as one of the platinum sponsors of this conference. It is my first time attending this conference, and I found it to be just wonderful so far. Really interesting talks and really great people, and hope that it continues into perpetuity. So I'm from the Massachusetts Green High Performance Computing Center. It's a collaboration of MIT, Harvard, BU Northeastern, and UMass in Holyoke, Massachusetts. And I can tell you more about that during the breaks. On all of our slides for Open On Demand, my colleague Alan Chalker is very good at creating short URLs so that they're easy to type, usually in the bottom right-hand corner of the slide. So if you want to learn more about anything that I'm going to talk about today, you can type in that URL or just go to openondemand.org and navigate through the normal methods. So Open On Demand, for anyone who's not familiar with it, is a platform that greatly simplifies access to supercomputing resources by putting a very user-friendly web front end onto supercomputers. So it turns your supercomputer that would traditionally be reached through SSH and schedulers into just another web browser. And suddenly you have this very, very fast computer on your desk. So looking at it from a user perspective, there's and the user could be a researcher, an educator, a research facilitator. There's zero installation. You just go to a website and you log in and you start using your resources. And so it's very easy to use. It's compatible with any device, which we'll demonstrate with a very quick video in a moment. And it really drastically simplifies the use of supercomputers for our end users. And here's the video. It is featuring my colleague, the face of Open On Demand, Alan Chalker, although you don't really see his face very much here. But you can see that you can really run on demand from anywhere. Your traditional laptop, your phone. From a system administrator perspective, it's only a little bit more complicated. Since the users are doing no installation, obviously the administrators of the systems do need to do an install, but I'm told that it can take as little as a few hours in an afternoon. And the code is free and open source, and we actually really welcome contributions from the community. And it's very configurable and flexible. And once you have it installed, you can really do a lot to customize Open On Demand to put your own branding on it and make it look like a resource from your data center. It's deployed worldwide. We're in 62 countries and about almost 700 organizations. We know that we're somewhat undercounting this because we derive this map. Each of these red dots we trace the IP addresses from our RMP records and logs, and that's what we're plotting. So we know that we're undercounting, but even so, it's growing quite rapidly. Even at PERC this year, we were just barely at the 500 mark. So just in a few months, we're seeing rapid deployment of Open On Demand. This is a list of some of the utilities and apps that we know that are being used with Open On Demand. Everything underlined is a utility, and the apps are not. And you can see it's a list of commonly used utilities and tools that people use when doing research computing. As we said, we're always welcoming contributions from the community. We know that there are many other apps out there, and we welcome contributions to our repos so that we can make these more well-known to others. So if you actually need support on Open On Demand, there's several ways to get it. We highly recommend joining our discourse site. For those of you that are not familiar with discourse, it's a Q&A platform, not to be confused with Discord, which any of you that have teenagers are probably familiar with. It's a very popular gaming chat site. Discourse is more of a traditional Q&A platform. Our developers are monitoring it constantly. We get really great feedback about the response time on Discourse. And we also really encourage community-to-community conversations on Discourse as well. If you get to our Discourse site, first you can look to see if your question has already been asked. And if it hasn't, we highly encourage you to ask the question, because then you're creating a record and an archive of the answer for the next person that has that question. It works really well. We see really great chats there, and oftentimes information that is on discourse turns either into a new feature request or even or sometimes a bug fix that needs to happen. We also have extensive documentation that was pretty much rewritten over the last year. So if you haven't checked our documentation in a little while, please go back and check it. And of course, if you don't see documentation for what you need, go back to discourse and ask for it. And finally, we have a newsletter. It's a constant contact newsletter where you can get information about upcoming events, training, as well as any new releases that are out. We also have a couple of regularly scheduled monthly events. Our tips and tricks call is on the first Thursday of every month. And it's an opportunity for the community as well as our developers to share tips and tricks. It's always really fun to see what other people are doing. We recently had a demo of a node monitoring application that was developed by Arizona State University. And it's hosted by actually a member of our community, Martin Kuma at the University of Utah. And you can go to our support site to get the URL for this. And the other, or you can actually go to ondemand.org/events. We also have open office hours. They're held on the second Tuesday of every month. And our developers, as well as most of our leadership team, shows up on that call. It's about an hour and a half. We kind of try to span three hours, so that even though it's only an hour and a half, and so that we can get as many people to at a convenient time. We are also hiring. We just recently received a new award from the NSF called POSE, and we're looking for development. It's a new role, actually. It's called the developer relations. So when you have open source code, you want to have relations with the community, sort of at the developer level. So it's like a traditional project manager role, but for not only for our own dev team, but also for the community. We're also looking for an expert in security. So please come talk to Alan or me or Chase in the booth if you'd like to know more about these roles. And with that, I would like to introduce our keynote speaker today, Wendy Nilsen, is a division director at the NSF in the Information and Intelligence Systems Division of Computer of SISE, of the SISE Directorate at NSF. And apologies, Wendy, that I kind of messed that up a little bit. Her focus has been on interdisciplinary science, especially at the intersection of computing and human functioning. And we're really thrilled to have her here today. And with that, let me introduce Wendy Nilsen.
I have actually had a fabulous time at this conference. I have learned things I didn't know. I have seen things that I hadn't expected to see. There's all sorts of very cool things happening. So thank you for having me here. I mean, I guess really mostly thanks for being here and doing what you do. But then thanks for letting me be a little part of this. So I really wanted to talk today, as Joe and I were talking when he originally called me on this. We got into the philosophical discussion about collaborations and the challenges of collaborations. And I have spent my life crossing boundaries, working across disciplines. Ever since I've come to the government, it's been one discipline after another that we go, whoa, look, there's an opportunity. Let's go talk over here. When I first started, really working in the area of computing and health, everybody kept saying to me, ooh, doctors, terrible, horrible. Ooh, those compute people. Or actually, it was never compute people, it was just engineers. Everybody's blankets, engineers or programmers or clinicians. So we have these lump categories, which, by the way, most of the people on either side would say, what? But it was like, they're such a pain to collaborate with. It's so hard. These were people I had actually funded to collaborate. So I can't even imagine what the rest of the world was saying. But it was pull me aside and say, you don't know what a pain they are. They want to meet at like 11 p.m. because they say they had surgery and they can't get out until then. And they'll meet at 11 and talk about a project. Who talks about a project at 11 p.m.? I'm like, yeah, people who were in surgery. But you know, how do you think about this? How do we think about collaboration in a way? Collaborations are relationships. So at some level, it's like when you were a little kid and, you know, somebody said to you, marriages are hard, relationships are hard, collaborations are hard. They're worth it, but they take a lot of work. So, and I think we often think because we're science, we're all beyond this, right? We're scientists. We know this is important. We can deal with this. But you know what the reality is? Oops, I'm not moving. I think this gets to what Amit was talking about yesterday. I thought Amit did a great job of talking about, are we computing in the center or for the external people, for our collaborators? Where is compute? Where is compute? Because we think it's in the center. And I spend my entire life telling everybody we're in the center. And then all my collaborators say, really? We're going to get the Nobel Prize. All right, yeah, you win. But the thing is, so how do we become in a world, how do we think about collaboration in a world where compute, I remember when we were talking about years and years ago, where computing was going to become so ubiquitous that it became invisible. And I think what I've heard here in all the talks is this attempt, this ability to think about, how does computing just become a part of the workflow? How does it just become a part? It becomes invisible, right? We aren't existing as a separate function. We're existing as a complementary function. What I want to think about is, how do we complement each other? Because my colleague, my collaborator may be getting the Nobel Prize at some point, maybe. But the thing is that I want to get a Turing Award, right? So how do we make these collaborations so that compute can stay in the middle, but in a way that works for everybody, including us? But we're in the silos. And I always show the silos because if we think we're not in silos, I think we make huge mistakes and miss opportunities. Because if we don't start walking up to the silos and we don't think about the silos, I can't tell you how many times I run an interagency working group in the government that focuses on the area of digital health. And I have my colleagues are always saying things like, oh yeah, you don't need that, you don't need that, you don't need this, you don't need that. Oh, by the way, we're going to do AI this week. We've decided we're going to use generative AI in everything we do. Isn't that great? And I'm like, whoa, time please, time please. But it's almost like we don't need each other. We've got these silos. I'm really good. You're really good, but we'll just keep working in parallel. And I think that's not the way the world's going to work. So I want to think about what makes these things so challenging. And this is what I want to spend my time thinking about today, is really what are the things that get in the way and how do we deal with them? And I think there's about 5 different things that make a difference. Although none of them are game stoppers, all of them are challenging. So the first thing is language. You know, we talk about a mouse, so that's easy. This is easy. We can negotiate the mouse question. But you know, one of the first meetings I ran when I came to NIH, whole room full of people just like this, many very, very prestigious compute people, lots of really prestigious health people. And we're going through the list of things, sorry, that you can and cannot do in this big new center that we're kicking off. And so one of the things so I made an announcement and I said, by the way, dissemination research is not an option in this center. We're early stage work, dissemination doesn't make sense. With that, one of the leaders of this area of computing stood up and said, you ruined my career. Whoops. All right, now I've blown it. Oh my gosh, furious, screaming. Okay, so finally I get to the point where, all right, can I understand what you mean by dissemination? User studies, testing us out with real people. And so I said to my NIH colleagues, what's dissemination mean to you? And they said, oh, after you did pilot studies, randomized trials, you're getting ready to go to FDA, you're rolling this out to the community. We then get to dissemination and implementation. And the compute folks looked and said, "Ew, we don't do that." It's like, so nobody got their life ruined. Nobody got their, and this happened again and again and again. We would go to a meeting, we would somebody'd start talking about ground truth. The health people would say, "What is a ground truth? Like, what are you talking about? There's no such thing as truth." Because in health, we have gold standards. And gold standard, when the health people would be talking about gold standards, people were saying, "Why do they keep talking about money?" So we were stuck. We have these impasses in language. These are not big impasses. There are so many times if you ever come to an NSF panel, you should all come because it's a fun place to be. But we'll tell you to spell out every acronym, because the acronym you think is normal is completely different in the next division. I will tell you, it's so funny. We'll do this all the time. Learning the language is a challenge. It's like any other going to another country, thinking about that. You want to partner, you want to collaborate, you need to be able to, you don't have to become an expert in biology, but you have to have enough language to get through a conversation. You have to have enough language to, when somebody says something to you, you don't look at them and go, "Start from the beginning, please." You have to be able to do that. So thinking about the language, I think, is a critical piece. I actually think the language is so critical, because this is an example. This is just a section I pulled out of one of my reports from a proposal that was funded 5 years ago. Actually, it's 7 years ago now. They had 50 papers published on this award. Fabulous, right? Great. The kicker was, this was a project that was using computer vision and sensing, tactile sensing, to do physical therapy. So they wanted to be able to give the care provider feedback, because often when you do physical therapy, somebody helps somebody. So if you're doing physical therapy at home, your mom had a stroke, you're probably there helping her balance, but nobody knows how hard you're pushing, how hard you're holding up. So this team decided they could use computer vision and sensing, merge it into a visualization for the providers. Great idea, super idea, all sorts of cool studies, all sorts of cool projects. Out of 50 projects, the words physical therapy appeared twice. Now, is that bad? No, not at all. But all I'm saying is, if I want to partner with this person, well, I know this is somebody who's ever worked in the health space before. Look at some of the titles. I mean, some of them are okay, but efficient hand tracking using adaptive hand model and depth maps, it's super cool. But doesn't mean anything. It doesn't mean anything if I'm on a biomed side. So we don't even have papers talking to each other. So the language problem becomes even more severe, because if I go in and I want to see who's doing computer vision and physical therapy, I don't get a whole lot. And actually, we started running experiments on this, because somebody was saying, well, of course we can cross-reference them. We can, because we have the grant number, and we can cross-reference on that. That was the only way we picked up all these different articles. So we have a problem not only talking to each other, but even talking across the disciplines in the journals. And we're talking to people now about, can you add keywords? Can you add different words in there to help the rest of the community? So as you're doing projects, if you're doing collaborative work, think about, what are the keywords that are going to help somebody else who's not like me find me, right? Because at some level, that's one of the joys of collaboration, when they come looking for you, when you're not looking for them. So we have these challenges. The cultures are also very different. We just did a project. We were doing a project at NSF, and they wanted to talk about health in a context we had never talked about it before. And somebody said, well, we could make these very, very teeny grants. You know, you don't have to pay people much. We could make them very teeny, 200,000. And I said, do you realize you're working with people on soft money? And my colleagues looked at me and said, what's soft money mean? So what happens when you have people who are only 30% of their salary is paid by their contract, right? And that's what happens if you're in a med center. For the most part, you're getting 30% of your salary paid. The rest of it you're earning from grants. So that makes a very, very different world than if you're on a 9-month teaching, you know, and you're teaching a research position, and you're using your research money to get extra money from the summer. So it's a very, very different cultural world, because a $200,000 award, you might say, oh, that's cool. I could get some students. This would be great. If you're on soft money, that's just taking time that isn't going to get you paid. So we have to think about those cultural things. We have to think about publications. I used to co-lead a conference called Wireless Health. And we made wireless health to bring together the biomedical and the technical community, so engineering and computing. And we started this conference and we thought, oh, this is easy. We'll just, solicit papers. We'll hold it at NIH. It'll work. This will work. We got there and we had so much complaining. People were leaving, unlike this one, with good food, a good agenda and a good program and a great team running it. We did not win any of those awards. We had people streaming out. We had people sound asleep at the table. It was amazing. So what happened was, my biomed people are senior, because senior people are the ones that talk at conferences, right? Junior people, students and junior people do posters in the biomed world, not talk. So only the senior people are talking. They're talking heavily biomed. So the technical folks are going, great, not sure what they're talking about. There's one point where there's a bloody scene on the screen, and that's where I'm like, oh God, what are we doing here? There's like this bloody hip in the thing. Like, we don't need to see this. It's not effective. So, but the other thing was, the biomed people were saying, why are all these students presenting? Didn't anybody want to come who was qualified? Now, I know why all our students were presenting. I was proud of that. But the fact that the two cultures didn't understand each other at all. By the way, if you're in the life sciences biomed world, conference proceedings are not helping you, right? So we've done these big workshops with NIH, and we get all done, and everybody from the NSF side says, we're going to put out a paper, we're going to do an IEEE something, communications or something paper, and they're like, ew, why? Who will read that? So we end up having to publish 2 papers every time. So, if you think about this, this is to get around the cultural things. I want people from both sides to be rewarded. By the way, I don't publish them, but I want people, the PIs and all the teams that are working on these projects, to get credit for it, to get these publications for it, and to have it count. But we have to take the time and understand what's working for you. How are you getting tenure? Recently, I was in a National Academies panel, and one of the very well-known researchers said, the data science people drive me nuts. It seems like they always they look at me, and I'm supposed to deal with this. I'm supposed to deal with this for all of us, right? So I go, excuse me? He goes, they drive me nuts. I said, so what drives you nuts? Here we are, we're on National Academies, we're being video cast, and here we're going to have this conversation. So he says, all they want to do is play with my data. I want to save lives. They want to play with data. So I said, well, that's interesting, because I'm pretty sure if I asked your data science colleagues, did they want to save lives? What would their answer be? And he looks at me, I said, oh, I'm sure they want to save lives. I'm 100% sure. But do you know what they need to do to get tenured? I said, you might save lives, do all sorts of things, get a New England Journal, a Lancet. Unless you're getting a science paper out of it, they need publications out of it. They need new ways to do things. They need new methods. They need new things to write grants about. And he's looking at me, goes, well, why wouldn't mine count? Why wouldn't what I'm doing count? This is more important. And I said, it's more important for so many levels, but it's not more important than other people's careers. So understanding how both sides work, I think, is really critical. It's really easy to get irritated, like this guy did, when it really isn't an irritating thing. It's an understanding. If you want to play with my data, what is your goal here? What kind of things do you need to do? And by the way, I would never suggest partnering with anybody who says, all you want to do is play with my data. I actually told him that. You would never be somebody that I encourage people to partner with, because this isn't really a great show of empathy here for your colleagues. At which point he came back later and said, I'm really sorry, I think I was a jerk. I was really happy. So, but thinking about, how do we think about these cultural issues? How do we think about how salaries are paid? They're very different. Also thinking about grant funding. When you write with somebody who works with another funder, I've run a program for years that crossed NIH and NSF, but it was an NSF review. And I constantly get things that have specific aims, and those specific aims are to cure a disease. And I'm all for curing diseases, but that's what NIH does for a living. So I want them to go there. But people don't even realize there's a completely different culture around a grant for NSF than a grant for NIH. And even when we come together in a partnership, it's NIH stepping out of their comfort zone to partner with us. I also think, knowledge is a big deal. We're in academia, we value knowledge, we're smart, right? We're a whole bunch of smart people that come together. When you partner, when you collaborate, you feel stupid. And last night at dinner, I was saying, when I first came to government, I went to a conference and I was sitting there and I was trying to look interested. Oh my gosh, I was trying to look interested through this tutorial. And it must have been obvious because the guy next to me at some point stabs me in the elbow and says, "You're not an engineer, are you?" I said, "No." And he said, so he basically said, "Would you like me to explain what's happening over lunch so that you have a framework to think about what they're talking about?" And I said, "Yeah, I'd love that." Which, think about how lucky I was to be, this was actually, the person I was sitting next to was an engineer who was a reporter. So he had like this massive skill set because he could communicate anything and actually liked talking to people. So I was like super, super lucky to have this guy next to me. But he spent the entire lunch hour giving me a framework so that when I walk back in, I can go, now, I'm still no expert in this field, but I have a schema now in my head to understand what they're talking about. And now I can start to write down questions that I can then discreetly ask somebody afterwards, right? Because I'm not going to raise my hand and say, "Hi, I'm the stupid one here." But I had to be comfortable with being, hi, you don't want to be the one under the elephant, but you want to be the one who feels comfortable enough to say, "I don't know what you're talking about. Can you help me?" That's really hard. And especially in academia where we value knowledge so much. But really, collaboration is all about being willing to say, "I don't know. I don't know what we're doing here." And it's trial and error. It's learning that way. I think the bigger thing is for all of this too, the incentives are misaligned. We have incentives. We're all trying to get tenure in all different ways. But what we have is we have very, very different systems. We're not rewarding, I would like to think we're rewarding the best science regardless. So whether I'm in compute, whether I'm in engineering, whether I'm in a biomed program, whether I'm in a hospital program, I'd like to think, if I got the top paper at a conference, that would have been fabulous. But that's not really the way the world works. So if you're in a university where it does, which some of them are moving toward this, yes. If not, you're stuck with trying to figure out how do you negotiate those different boundaries? How do you deal with the time? There's a whole research in the world of team science that shows that collaborations are hard on junior faculty. Why? Who is the most likely to want to collaborate, by the way? It's junior faculty. They see the problems. They're big, ugly, wicked problems. They want to make a difference. So they're looking for those collaborations, which is really, really good. But why is it hard on their career? Because it takes time, right? I can't just walk up and say, "Hi, let's partner. We're going to be BFF from now on. From now on, we'll speak the same language. We'll be completely aligned." It's going to take visits. It's going to take trips. It's going to take calls. It's going to take at least a lot of Zoom, if nothing else. But it's going to take that time to build that relationship. And often those projects are more complicated, which means more time, more money. And you remember, sometimes the wicked problems are hard to get funded. So, I would love to fund a project that would transform digital literacy for the whole world. Yeah, we'd all of a sudden make it so everybody understood what the risks and benefits were. I can just imagine what would happen in panel. This is just too big a topic, right? Scale it down. Let's make it smaller. So sometimes those big wicked problems, because they're big and wicked, are really hard to manage to do. So, and teaching loads, never forget teaching loads or clinical loads, because remember, if you only have 30% of your salary paid and you don't have enough grants, that means clinic time for many of the biomed people. So there's different, it's teaching, it's clinical, it's a whole lot of different things, but that's going to change how their availability is. So, context is important. I love this one because, shepherd's pie at the Stephen King Diner is very different than shepherd's pie anywhere else. But, keeping that context in mind, because what something means to you in your context is going to be something different to somebody else and to your collaborators. The last thing is location. And I was reading an article the other day and it was saying the death of distance. And I think we'd all love to believe that the death of distance had happened during COVID, right? So there is no such thing as distance. I can partner with my colleagues in India right now, although they're probably asleep, or they're probably getting ready for bed at this point, right? So, is there a death of distance? Sometimes collaboration really requires the time. It requires the travel. It requires getting to know people. It requires getting to spend time. We funded projects earlier this year, last summer, where teams came from the US and Australia. And it was interesting, after we funded the teams, as we were talking to them, all of them made a quick trip to Australia to write proposals. So they could meet with the whole team, so they could really get to talk. Now, that's a pretty nice luxury, to be able to fly to Australia and to work with your team. I'm glad they did it though, because I think that's what helps make a really good proposal. But that kind of partnership takes time, it takes money, it takes effort to do that. And so building those teams takes time. And by the way, one of the things that always made me laugh was, people would say, I'll just walk over to the med school. Med schools aren't even always on the same campus. Sometimes they're actually, I was in New York for years, and Syracuse University's med school is in New York City. The rest of the campus is in Syracuse, so you're lucky one way or another. You can choose which side you'd rather be on. But the thing is that you're not going to walk across campus. And even if you can walk across campus, in my university, there was a river and a cemetery between the academic campus and the med school. So we made real sure that you couldn't get there easily. So there was no way to walk over. So, it's not like it's walking down the hall for you. It's not like it's just walking across the courtyard to get to someone. So you might say, you talked about all these problems in collaboration. Can't we just, I'm thinking of Andy yesterday talking about, bringing all the knowledge together, the Library of Alexandria. Can't we just build a portal to match people, right? So I actually went to one of the big tech companies and said, can you help me with this? Can we think about taking publication data and figuring out a way to create match? I want to create eHarmony, which, we wouldn't call it eHarmony, but I want to create eHarmony for science. Can we do this? They were like, oh, sure, that should be doable. Well, as soon as we dug into this, do you know how hard this problem is? So what qualifies you to be an X? What qualifies you to be, if you say I'm computing, then I have to give you all the categories of computing, right? Then I have to explain them all, because how do I know who I want? Do I want a supercomputer person? Yes, of course I do. Supercomputing, that sounds so good. I want a supercomputing person, right? And then they call you and you go, nah, you don't really want me. Oh, wait, I could probably be helpful, but what you're looking for is this. People just don't know. It's the same thing as when I get people who say, I'm going to do congestive heart failure. And so I found this surgeon to talk to. Well, surgeons don't tend to do congestive heart failure. So all of a sudden you get this whole different world where you need to match the expertise you need to the problems that you're trying to address. We have uber specialization in so many areas. Then we got to the things. So what makes you qualified? Is it one publication? Is it two? Is it three? Is it a grant? Well, I'd like to think that people that don't get grant funded have great ideas too. So it wouldn't be a grant, but how many papers do you have to have? What kind of papers do you have to have? In the biomed world, there's all sorts of pay for play journals. right? You can get a lot of really crappy science out there with a checkbook. So what do? So we went and we hashed around and around and around. And after about a year, we said, we can't really figure out how to make this work. So if anybody can figure out how to make it work, let me know. I'm still willing to try to do this if we can figure it out. But it really was, I kept coming back to, it almost requires us to get to know somebody, to look for a person versus being able to just plug in. Maybe it would be just as effective as eHarmony, right? Maybe that's the problem. We wouldn't really get what we needed. So collaboration, again, it's always a bear. This is the, this is the one about the problem needs to be addressed ASAP. Well, this is clearly an HR issue. What does HR issue say? No, that's not us. Go talk to IT. IT says, you see, they started marketing, by the way. When they get to IT, what's IT say? This is a marketing problem. So, this is kind of collaboration as we until we figure out who are we working with, who's responsible, how do we work together on these things? So really thinking about bridging between communities. See, I like the little tapis bowl, by the way. So there was an icon, so I picked it up. So now I'm advertising for the tapis bowl. But building these bridges between our sciences, between our users, between our systems is really going to be key. If we're going to solve the problems that are challenging our world, whether it be health, whether it be poverty, whether it be climate, whether it be any of these things, information, misinformation, we really need to bring people together. And we need to remember that this is really hard, but it's worthwhile. And I think one of the things that I've seen in years of working across these boundaries is that wicked problems really bring out the best in people. So doing these really hard problems, for the most part, brings out really interesting things in folks. It also brings people resources. One of the things, once people get done in the first year complaining about how crappy their partners are, by the second year, they're absolutely fascinated by the resources their partners bring to bear. So I funded a project once and I said, I've got to cut $200,000 off your funding to make this work. Can you make this work? And if so, how much would it hurt your project? And the PI said, oh my God, you can't do that. We have time on a MRI, a magnetic resonance imaging machine, and they're super duper expensive. This will kill my project. And I said, okay, let's figure out what we can do here. Talk to your collaborators, see what happens, and let's connect tomorrow and figure out what's going to happen. So the person called their biomed colleague. The biomed person got their dean on the phone and said, this is what we're trying to do. And the dean went, oh my gosh, that's magical. You can have all the MRI time you want. We'll give you all the downtime, which I'm pretty sure they didn't give them all they wanted, but they gave them a lot. And they still are giving them a lot, by the way. The project's finished and they're still giving them time, and on a project that's going to be pretty transformative. But the thing was that they ended up with resources. And they've also ended up with a ton of med students involved in this project, because the dean has been the biggest proponent for this. So the dean is saying to the med students, if you want to know what medicine's going to look like in 10 years, join this project. This is a robotic project, so very different world. So, it's gotten to the point where, and then what's really interesting is we have all of our compute students are now hanging out in the med school, learning about these problems, and understanding it, building a whole new language, understanding the culture. It's really hysterical when we have these conversations and they say, have you ever seen a pipette? Because pipettes are pretty archaic when you look at them, let's squirt stuff into test tubes. But it makes people laugh. When you're used to a circuit world, a pipette is something really wild. So, but graduate students spend lots of time with pipettes in the biomed world. So, getting each one to understand each other has been amazing. And also, I think the biggest thing that what we get with these wicked problems and with these collaborations is impact. I do want to talk a little bit about one of the things about teams that I think is really important. This is an article from 2007, but looking at the increase in the amount of team science done. So if you look at it on one side, it's 1, 2, 3, 4 members. You can see in the sciences and engineering, there's a dramatic increase, and I'm sure it's still going up. And the percentage of papers are coming up with multiple authors. So these collaborations are happening, but how do we make them happen successfully is the things that I'm thinking about. There is a field on this. For those of you that are really interested in collaboration, there's a field called team science. You all know about team science? This seems like a group that might have a toehold in the team science world. If you don't, grab a team science person and hang out with them. This is what they do for a living. They help you try to figure out what kind of things make it, where are the places that teams go wrong? Where are the places that teams go right? How do you think about this? So there's been a lot of the team science work looks at, like publications, authorship. This is a real challenge when you have big teams that cross boundaries. Who gets what, who's who, who's what? How do we think about that? If you start to work all that stuff out in advance, you get a completely different team. The boundaries are all different. They're all set up in a better way. We also get expectations in. So talking about, how much time do you get? What other things are your plate? What other responsibilities do you have that are going to get in the way of this? So really having those expectations laid out for a good collaboration, understanding expectations is key, right? And then the evaluation. How do you evaluate what's working or not is a big thing in team science, because if you don't keep evaluating it, you can be going down the wrong pathway. So keeping your team healthy is really key. So, if you're interested, this is a National Academies report. Oops, it's in my slides. I'll leave my slides if you want them. But the National Academy is the work of the science of team science, has a lot of really interesting information on it, on teaming and on team science and on which is really the science of collaboration. So, you can't collaborate. You can't collaborate on your own. So, that's what it comes down to. If you want to do these cool things, and I saw so many cool things here yesterday, so I know you're doing them, is the collaboration part, doing the work for the collaboration, building those relationships, taking that time. There's some shortcuts you can do. You can always look at awards for NIH. You can look at awards for NSF. You can find people in your own state, in your own university. But then you have to take the time to go meet them, to talk to them, to build those relationships, read their articles, understand what they're doing. Hopefully they read yours and understand it too. This is the thing I live by, though. I think we get our big impact when we have the relationships. I think it's what Amit said yesterday, right? It's where we work together, where we come together, where the fundamental science questions get answered, and the other questions science are being answered in all sorts of ways in a seamless relationship. So with that, I'm gonna be available for questions. So.